Hello Math 110 class, and welcome to section 4.5, where we'll be talking about properties of logarithms. The goal ultimately will be later in the section here to solve or simplify some expressions and ultimately solve equations. So let's first get started with what are known as the laws of logarithms. So here we're going to assume u and w are positive numbers. Otherwise, the individual logarithms won't make sense. But first, we have the log base a of a product, u times w. If you've had practice with this before, you'll know that that is the log base a of the first factor, which is u, plus the log base a of the second factor, which is w. Here, division within a logarithm, well, if multiplication corresponded to addition outside the logarithm, then division within a logarithm will correspond to subtraction outside the logarithms. And here the order matters. Notice it's u over w, so it'll be log base a of u minus log base a of w. And then here, this is something of an interesting property of logarithms, but the log base a of u to the power c will be, you can actually bring the power down, so it's c times log base a of u. So technically there's multiplication right there. And now one quick remark here is that all of these rules also hold for the natural logarithm, because that's just log base e, and this number a here is just a positive number that's not equal to 1. So certainly e is such a number, and so you can have ln all of filled in all here, and it would still work. Okay, one cautionary note for you is that there's no way to simplify these two. The log base a of u plus w. Notice the plus is now inside the logarithm, and log base a of u minus w. These don't simplify. Okay. So when you have something like this, you can't split it up in any meaningful way. Okay, so let's use these properties 1, 2, and 3 to simplify some logarithms here. So first thing we're going to note is that we have a big division bar in our problem inside this logarithm. So I think rule 2 is going to tell us that this is the log base 3 of xz, which is the top, minus the log base 3 of y, which is the bottom. And so just to scroll back up here, you see we're using this property right here. And so xz was in the numerator inside the logarithm. Okay, and now using property 1, we have a product inside this logarithm. So this is the log base 3 of x plus the log base 3 of z, and now don't forget this, minus log base 3 of y. Okay, and that's pretty much it. We've totally separated this logarithm into its own separate logarithms. Okay, so moving here, we're first going to use property 3, so that you'll notice we have a whole expression here underneath this fourth root. Well, the first thing we're going to do is we're going to make that the ln of x to the 7 over y to the 5th z, and the fourth root is the same as the 1/4 power. So fourth root, think of a radical as an exponent, 1 over whatever the index of the root is. So in this case it's 1/4. Okay, so using property 3, we see that we have an expression raised to the power, in this case 1/4. So that 1/4 will come out front like so. And now we see that we can apply maybe properties 2 and 1 as we go along. So let's see, we get, now let's be careful here. We have this 1/4 out front, and we're going to be separating this logarithm, so this 1/4 is going to distribute. So we get ln x to the 7 minus ln y to the 5z. And if you like, you can distribute the 1/4 now. And so you get 1/4 ln x to the 7 minus 1/4 ln y to the 5z. And now let's work with each of these individually. So here, property 3 tells us that the 7 can come down and multiply to the 1/4. And so what we get is we get 7/4 ln x minus, and now we need to be careful here. The 5 doesn't automatically come down. You'll notice that it's being stuck next to this z here. So I think we get something like ln y to the 5. So first we're going to split this up. Plus ln of z. And now distribute the 1/4 and maybe even bring down, well, let's do this one at a time here. So 7/4 ln x minus 1/4 ln y to the 5th minus 1/4 ln z. And now we finally see that we can bring this 5 down and multiply the 1/4. So I think our final answer is going to be 7/4 ln x minus 5/4 ln y minus 1/4 ln z. And so an observation to make is that you'll notice way back in the original problem, the y to the 5th and the z were originally in the denominator, and that corresponds always to minus signs being in front of their expanded terms. And you'll notice the x to the 7 was in the numerator, and it technically has a positive here, right? So that's something we're going to be trying to leverage moving forward. Okay, so now this one, you'll notice that the radical is not over the whole expression like it was before. And so what we're going to do is we can't just make everything, let's say, to the 1/2 power like we did in the last one, because it's only affecting the y. And similarly here, this cube root is only affecting the z. So we're going to actually do those individually first, like so. And now we're going to use this observation from before, that we have this in the numerator and these two in the denominator. And so I think we're going to get something like this, that there's a log y to the 1/2, but when we split it up, the x to the 4th will have a minus in front of it because it's in the denominator, and similarly the z to the 1/3 will also have a minus in front of it, or the log of z to the 1/3 will have a minus in front of it because it's also in the denominator inside this logarithm. And now just use property 3 to bring down those powers. And it's worth remarking here that log, if there's no number down here, this is what's known as the common logarithm or the base 10 logarithm. So I'll say log equals log base 10. That's really what that means. So just like ln means log base e, log means log base 10. Okay, and now here, this final one, this is a base a. You'll notice we have two things in the numerator and two things in the denominator. So I think what we're going to get is for every factor in the numerator, so here I have two factors, x cubed and w, they'll each have, or they'll each be positive, I guess you could say. And I have two factors in the denominator, and so each of those will have a minus in front of their logarithms. And now we just use property 3 to bring down those exponents there. So this is 3 log base a of x plus log base a of w minus 2 log base a of y minus 4 log, sorry, this should be base a of z. So that's it for those type of problems. Now we're going to work backwards. You'll notice way up here that this is an equal sign, so it also works backwards, right? So I can take two logarithms of the same base and recombine them into a single logarithm in the following three ways, right? So let's see if we can use that to our advantage. All right, so looking here, well, they both have the same base, so check. And now there's a minus between them, so this is really just the log base 4. This goes in the numerator, this goes in the denominator. So x over 7y. Okay. Now here, these are all base A, so that's good. First thing I'm going to do is use part 3 to pull these powers back up. Since I'm condensing, I want all these powers back up in front of the logarithms. So this is log base A x squared minus log base A of x minus 2. Now put parentheses around that to the 1/3. And minus log base A of, now put parentheses around 2x plus 3. And that's all to the 5th power, right? And now here, let's work backwards. So these two logarithms have minuses in front of them, which means that their corresponding inputs will be in the denominator of the new logarithm. So all the bases are the same. This condenses to one single log base A. The thing on the numerator is anything with a positive log, so that's the x squared. And the denominator comprises of things with minuses in front of the log. So we get x minus 2 to the 1/3. And this will also be in the denominator, 2x plus 3 to the 5th. Okay, and now here, let's first move these powers back up. So I get log y cubed squared, which will simplify shortly, minus log y cubed, and then here I get plus log of x to the 4 y squared, all to the 1/2 power. So let's use rules of exponents here. Raise a power to a power means you multiply them, so this is the log of y to the 6. And here, because I have multiplication here, I just give the power to each of them. So that's x to the 4th to the 1/2, which is x squared. And y squared to the 1/2 is just y. Okay, and now let's simplify. So this log has a minus, so the y cubed will be in the denominator of the new single logarithm, whereas this and this will be in the numerator. So this is log y to the 6 times x squared times y all over y cubed. And I think we can simplify this. This is log, here I have y to the 7. I add the powers, that's technically a y to the 1st there. Divided by y cubed is y to the 4 in the numerator. And I also have that x squared in the numerator. All right, and now ultimately this is a pre-calculus / algebra class. So we're going to use these properties to now solve equations. So if you have two logs, or if you have a log with only one base throughout the whole problem, then recombine both sides. So there's nothing I can do with this side. This is log base b of 2x minus 3. But here I can recombine this to log base b of 24 over 3, which is 8, right? So this is log base b of 8. And now you'll notice that the bases of the logarithm are the same. So that means that this expression right here has to equal this expression right here. So this implies that 2x minus 3 has to equal 8. And you solve it, and you get x equals 11 over 2. And now you just need to check that your answer is valid. The only place x exists is over here, and if I plug in 11 over 2, you get 8 inside the logarithm, which is okay. So this checks out, it's valid. All right, so now coming over here, we're going to recombine both sides. So here this is ln x times x plus 6, and this equals ln 49 to the 1/2. If you're familiar with your square roots of 49, that's actually 7. And here I get ln of the expression x squared plus 6x, right? If I just simplify, distribute within the logarithm, I get that. Okay, well that tells me then that x squared plus 6x has to equal 7. And the way we solve quadratics is we move everything to one side and factor if possible. So I think I get plus 7 minus 1. And this says that x equals minus 7 and x equals positive 1. And now check which one is valid, and if there are any. It looks like 1 works, but negative 7 is no good, right? Because it would make the logarithm have a negative input. So I think this one's not valid, but this one is. So that would be your only valid solution there. Okay, and now finally, if you don't have a logarithm on the other side, here's what we're going to do. We're first going to recombine the left-hand side. So this is log base 3 of x plus 3, and use parentheses for goodness sake. And x plus 5 equals 1. If you like, you can simplify this. So we get log base 3. Now within this logarithm, this is x squared plus 8x plus 15. And now let's make a triangle. So on the bottom of the triangle goes the base of the logarithm and its input. And on the top of the triangle goes the other side, so the 1. And now, oh look, this I can actually convert to an exponential statement. So what this says is that 3 to the first equals x squared plus 8x plus 15. Well, that's just 3, and so to solve this quadratic, I subtract 3 from both sides, and I get this here, x squared plus 8x plus 12, which I can factor as x plus 6, x plus 2, and this tells me that x equals minus 6 and x equals minus 2. And now we go back and check, are either of these valid? Well, the negative 6 is not. Notice you'll get a negative 3 inside the logarithm. So automatically game over for that one. Whereas negative 2 I think is, because here I get a 1 inside this logarithm, and here I get a 3. So I think this one works. And so our only valid solution here is x equals negative 2. Okay, so that's it for this video. In the next video, we'll cover section 4.6.